Hello and welcome. Um, Embedded Linux. What we should be knowing in Embedded Linux so that we can become an embedded developer. So let's look at the course from our Embedded Linux online course. So the demand for embedded Linux engineers with the requisite experience in Linux is on the rise. This online embedded course teaches how to configure the Linux kernel, develop custom peripheral drivers. Learners gain access to understanding of the Linux architecture and acquire practical skills involved in building an embedded Linux system as well as debugging and profiling application performance. The course aim is to learn how to develop Linux on embedded systems using low-cost yet powerful ARM-based platform, including custom peripheral development for various applications with standard industrial software tools. So the learning outcomes: the embedded Linux operating system architecture, Linux-based embedded system component stack, Linux kernel modules, system configuration and boot process, communication between kernel space and user space, system debugging and profiling. The intellectual ability that's expected to have, and we are saying that we have experience in embedded Linux, is the ability to select software tools for development of an embedded Linux system, as well as the ability to evaluate implementation results, for example, speed, cost, and power, and correlate them to appropriate system. The practical aspects: the ability to use industry standard tools to configure and build embedded Linux stack, ability to develop kernel modules for customer peripherals such as sensors, ability to debug system, debug and profile embedded Linux system using standard industry software tool. Let's look at the syllabus that's ARM expected people to have the knowledge about. First of all, you'll go to the introduction to Linux and embedded system, then Linux-based embedded system component stack, the anatomy of Linux-based system, configuration and build process, the Linux kernel modules, the communication between kernel and user space, the application demo, building and writing sensor kernel module. That's a live application demo that can get you familiarized with the total development process of developing a kernel module. Then system debugging and profiling. So in the ARM course, it's like 90 days access is $16. It's cheap. So, but certification is I guess is separate. So ARM has actually provided an free resource like the operating system foundation with Linux on Raspberry Pi. Let us look at that. So this is hosted on the GitHub site, and you can download the book here. You click on the download raw file, then the file opens in a separate window. Just for briefly looking through, we'll go to odd spreads and then fit to page and go through the table of contents. This is the operating system foundations with Linux on Raspberry Pi. So this is a 2019 edition. So Raspberry Pi operating system, which has evolved since then, but this book particularly enables us to look at the system programming and what operating systems how it's being programmed, low level details. Let's look at the table of contents. So first we go to memory centric system model. So modeling of memory, bare bones processor model, then advanced of processor model, then basic operating system concepts. These are pretty much detailed understanding of how the computing hardware can be made, programmed from an operating system implementation point of view. So then you go to the practical view of the Linux system, like basic concept like file storage, processes, the operating system hierarchy, user space and kernel space. Then the booting of Linux on the ARM is detailed. Then kernel administration and programming is detailed. Kernel administration, programming, process management, process scheduling, memory management, concurrency and parallel, input output, persistent storage. Then we go to hardware architecture, particularly for Cortex M0 plus A53. Process management is now examined in detail. The process abstraction, process metadata, process state transition, context switch, signal communication. Then we go to process scheduling. System calls scheduling principles, scheduling criteria. So the details of scheduling is there. Then we go to memory management in detail. Concurrency and parallelism next detailed. Then we go to input output. So managing I/O interaction, non-blocking I/O. These are treated in here. Persistent storage is detailed in the next topic. Then we come to networking. And lastly, advanced topics are dealt with in the chapter 11. So even if you do not understand the full detail of each and every topic here, it is good to skim through the materials and understand what all exists before we even try to understand them. So it's a very good exercise to go through all topics in this book at a bird's eye view level, so that you can go into these topics in detail when a need occurs. Hope it's been helpful. Thank you for listening. See you next time.